So let's talk some more about Google Web Toolkit. So Google Web Toolkit architecture best practices. This is what I'm going to cover today. It is how to organize a non-trivial application. So how to take a complex application and write it in such a way that it's easy to maintain, easy to test. We're going to focus on the client side, so the user interface inside the browser in GWT. And we're going to use lessons learned from the new AdWords user interface. This was relaunched a few months ago, was rewritten from the ground up using GWT. And here are some screenshots from that new user interface. So you can see this is not a very easy application. There's a lot of stuff happening, a lot of complex code, and there's constantly changes that need to happen. If you have to leave the session early, there's a few things I want you to kind of remember and think about. Or these are things you can think about as we go through the session. Make sure you get browser history right. So the back button and the forward button in the browser should work really well in your web application. Use an event bus to avoid spaghetti. You know when you start building an application, you have lots of little pieces, lots of little classes, and they're all tied together in different places. And it's mangled up, and you can't move one piece around without breaking 5 things. For that, you can use the event bus to kind of separate things out. And I'll show you how that works. DI plus MVP, FTW. And I should explain what that is, of course. DI is dependency injection. This is kind of a pattern for developing code that makes dependencies much easier to deal with. MVP is ModelViewPresenter. It's kind of like ModelViewController, but it works a little bit better, is more testable, and is faster. FTW means for the win, for success. We have 3 major themes today. We want to embrace asynchrony. That just means understand that the browser is asynchronous. When you make a call to the server, it takes some time before the server responds. It's never immediate. So you should just live with that and build with that pattern in mind. Always be decoupling. Always take the left side of your application and the right side and separate them out. There should be no connections going between all the different components. And strive to achieve statelessness. So first theme, embrace asynchrony. Well, remember that AJAX stands for Asynchronous JavaScript and XML. So you might write something like this when you start writing a contract. Let's say we build an application like a contact database. And we have contacts in there, like I'm a contact and there's phone numbers for me. 2 phone numbers and an email address. Then you're in there as a contact and you have a few phone numbers and a few email addresses. So that's what a contact is. A phone number is a contact detail. So you might do something like this. You have a string to store the name, and you have a list to store the details, and then you have a method to get those details and a method to get the name. So that looks kind of good, except there's a problem here. And the problem is that if you have, say, 500 contacts in your contact database, when the user opens up the application and tries to search the contacts, and you pull these 500 contacts down from the web server, you have to pull in all the contact details. So 500 names, maybe 1,000 email addresses, maybe 1,200 phone numbers, all have to come down over the network, which is slow. So that doesn't work very well. So what's better? Well, instead of contact details, we should maybe just pass down the IDs. So we have the phone number ID, maybe 5 or 42 or 127. And then when we need to, we can later fetch the details that we need. So if I click on one contact, then I go to the server and ask for the email addresses and phone numbers. So I can use my communication channel with the server much more efficiently. If you To kind of use this pattern, you get a nice leverage point, a place where you can do caching. You can batch up multiple commands. And you can centralize failure handling. So you can handle failures in one place. It also kind of lays the groundwork or prepares you for other things that you might want to do, like undo and redo capability. So how does that work? So let's look at some code. Now we use what we call the command pattern. So we send a command to the server. Because command is taken, I'll say action, but it's the same thing. So we have an interface action, and it's parameterized by a response. And then we have a simple response interface. So action is what goes from the client to the server, and the response is what comes back from the server to the client. If you already do GWT development, you're familiar with implementing an interface that you can use for RPC. And in this case, we have an execute interface. And we can send any action to this interface. We can send a get action, or a put action, or a delete action. This interface accepts all of those. Of course, we also need an asynchronous version of that same interface. And that's just standard GWT RPC. So we won't worry about that too much. So let's try to implement that. What does it look like? Let's say I want to get the details. I have my list of 500 contacts, and the user clicks on the third one and says, open that one up. So the editor needs to open up, and I need to see the phone numbers listed and the email addresses. So I need to contact to the server and say, give me the details. So that's this action right here, get details action. And it implements action, and is parameterized by get details response. So the response that I expect back from the server when I'm done is called a get details response. So I have a list of IDs. These are the detail IDs I want to know. So when I click on number 3 and I have these 5 IDs, I send those 5 IDs to the server, and then I get 5 details back. So on the client, when I construct this command, I need to give it the IDs I want. So I said this ID, this ID, this ID, this ID, and this ID. Those are the ones I want. When I receive the object on the server, when I receive this command on the server, I need a method to fetch the IDs, or to get them. So that's the getter. So this is very simple. It's kind of like an envelope or a package. I put in the IDs I want, and I send the action to the server, and the server takes the IDs out. And then it will create a response, put the details in, and send them back. So let's look at the response. Looks very similar. Get details response. I have some details. On the server, I have a constructor, so I can put the details in. And then on the client, when I receive the response, I need to pull the details back out. So it's very straightforward. We just have a message going that way and a message coming back. Now I want to make it a little bit easier to write the code. So I'm going to have this convenience class. It's an asynchronous callback. And I'm going to call this one got details. And it has an onFailure method. And here I put in all my error handling. And then an onSuccess method. And I call a new method called got. This is kind of the trick. So when you make an RPC call, you always have to pass in as another parameter the asynchronous callback handle. And you see this extends asynchronous callback. What I'm doing here is building a convenience class to make it easier. So I put the onSuccess method in there, and I put the onFailure method in there. So those are ready. I don't have to do those anymore. But in onSuccess, I call the got method. And I have to declare that. And I declare it as an abstract method. So later, I'm going to have to implement it. So when I use this, I only have to implement the got method. So that's what you see here. So if I have this list of 500 contacts and I click show, the action goes to the server, the response comes back, and then the got action is going to do the work. So you see that here. Service.execute, so we're executing a call on the server. And then we say new get details. So a new action, and we put in the detail IDs that we want. And then the next parameter is the asynchronous callback, that's the got details. And you see it's very simple. There's no onSuccess method and there's no onFailure method. We only implement the got method. And the got method says, when I receive my response and I have the details, then call render contact and render details. So imagine what happens. You have your list of 500 contacts and I click. That creates an action. The action goes to the server. The response comes back. And when the response comes back, then I show the contact and I show the details. So it's asynchronous. The second theme was to always decouple. So we want to talk about an event bus, dependency injection, and this ModelViewPresenter pattern. And those will give us some benefits. We will be easy to kind of rejigger the application, meaning take one piece of the application and move it over here, and take this piece and break it apart, so we can make changes quickly. We can do much easier unit testing, because everything's disconnected. We can take one piece out, then we can test it, and then put it back and take another piece out and test it. And you'll see we get fast test execution. So let's look at the event bus idea. Traditional design is kind of around the model. So you first create the model. So maybe we have contacts and groups of contacts, and those are wired directly to an RPC service. And then the widgets on the screen are bound to the model. And you probably have property change events. So when something changes in the model, you send a change event to the view. And when the view gets updated, like maybe someone edits a name, that goes back to the model. So everything's very tightly coupled together. Of course, you have more UI widgets. You also, you have a view and you have an edit version. So there's maybe 2 widgets. And they all have to be bound to the same model. Then at the top of the screen, you might have a title, which shows the current contact being viewed. You might have a breadcrumb, which shows the editing steps you've done. And now everything's tied together like spaghetti. And if I move anything, then everything breaks. And anytime I make a change, it's very difficult to follow how it propagates through. So the first thing to do is kind of decouple UI widgets. Widgets should not know about other widgets. So we separate them all apart, and we send everything through the event bus. So this looks a little bit better. But our problem is that we still have the model objects in the middle. So we have these event handlers that when the model changes, we send an event to the widget. And that just doesn't work very well. And we also have canonical version of the model objects. So that list of 500 contacts, that third one, here in the middle, there's only one copy of that model object. And so if I make any changes to it, I'm kind of updating a global version. And that's why I have to send those events to the other widgets to tell it that I've been updated. Now, if I have a little editor and I'm editing, then what happens when I hit cancel? Do I undo the model? And do I put it back in the old state? Do I only push the change once I've partially typed it? It gets kind of tricky. It's much easier if we just get rid of the canonical model objects and instead send copies of the objects over the wire. So you see here the model's in the middle, and there's only one copy of everything. Over here, the model objects just kind of float around, and there may be multiple copies. So what happens is when the server responds with the contact information, I have a model object. And I get it in the event bus, and I just send it around. I tell everyone, here's a new contact, and then everyone sees their copy. When I open up an editor, I just create a new copy of the contact, and I start changing it. If the user hits save, I take that second copy and send it on the event bus. If the user hits cancel, I just throw the model object away and I don't need it. And life becomes a lot simpler, because now the model objects no longer have on-property change events, and there's a lot less wiring. So the model is pretty simple. So what does that look like? Well, you remember this method. This was the last one we looked at, where we say show contact, we execute, and then render. First, we're going to just make a change. We're going to make sure that the model doesn't get into an infinite loop. So if an update comes in and it triggers an update, we don't want it to kind of flow back onto itself. So we simply add a special if check. Then on the event bus, we can do something interesting here. This is how we listen for events on the event bus. We say eventBus.addHandler, and we give it the type, which is the contact change event type. And then every time a contact changes, we look at it, and we say if current contact ID equals my contact ID, then do something. But if the contact ID coming in is for someone else, then I just ignore it. So this is a filter. This says only listen for contacts that are the same as the one that I'm showing. Now, what we also want to do is we want to put stuff on the event bus. So I first want to show you this. So when we make an RPC call to the server, then only the server knows about the change. What we really want is to notify the UI, notify the other parts of the application that the change happened, and tell the server. So what we do here is we create a fake service. This is kind of a dummy service as a wrapper. So we have the real service, and we have a fake service around it. And anytime I make a change, I call the fake service. And the fake service simply calls the real service and then does some extra stuff. So I'll show that here. So the fake service is, if it's a failure, pass through the failure. If it's successful, then I want to, so if I get a successful response from the server, I'm going to first update a local cache. And then I'm going to call the original onSuccess method. And then I'm going to create a new contact change event. And then I'm going to put this event on the event bus. So imagine how the flow works. I have a contact to change. I put it on the bus. Or sorry, I call the fake service, which calls the real service. The real service is over there. The real service responds on success. At that point, I update my local cache. I call the real onSuccess method. I create a new event, and I put the event on the bus. And the bus kind of tells the rest of my application. And this is the same thing, but just everything highlighted. So this is the final thing that I write. So it looks like a lot of code, but it's really pretty easy. We have a fake service, a real service, and on success, we just do a few things. Now another way we can decouple is ModelViewPresenter. You probably remember this diagram somewhere in your programming experience, ModelViewController. And maybe you understand it. I don't really understand it. And I think if I ask a lot of you, what does ModelViewController mean? I'll probably get a lot of different answers. One of the problems is no one really can agree on where to put the different pieces of functionality. So if I have some business logic, does that go in the controller or does that go in the model? If I want to have some complex changes in the UI, does that go in the view or does that go in the controller? It's a little, and if I have some model changes, model or view. The other problem is that these three pieces are tied together very tightly. And I can't really test any one of them. If I only test the model, then I have to somehow get a fake view and a fake controller. And if I want to test the controller, I need a fake view and a fake model. But all three are very complicated, so it's very hard to maintain the real version and then the fake version that you need to test with. And it's very brittle. It's easy to have bad tests. And then finally, the view is slow, because the real view is the web browser. And the web browser just takes a long time to start up. Unit tests are supposed to run really fast, so you can run lots and lots of tests, and you can do them inside the JVM. The web browser is just much, much slower than that. So to the rescue comes ModelViewPresenter. Here we make it very clear that there's only one relationship each way. Instead of everything being connected two different ways, now the model is only connected to the presenter. And the view is only connected to the presenter. And what we do is we further kind of simplify things, and we say, okay, the model, you make it as simple as possible. The model should just be properties, like a Java bean. Very simple properties. You have a name and a contact detail, something like that. That's it. The view can also be very simple. The view only needs to display a name or get a name. You need a couple of methods. All your business logic can go into the presenter, and it can all be written in Java. And when I do that, I can very easily create a mock for the model. I can very easily create a mock for the view. And I can test the presenter with unit tests. And I don't need a web browser. So the model is simply that class you saw at the very beginning, where we have a name. So this is a contact detail. We have a contact detail ID, we have a phone number, and then we have a label, which could be a work number or a home number. The editor, or the presenter, looks like this. It defines actually the view interface. And then the view is just widgets in the browser. But all the logic fits in the presenter in that middle tier. And remember, the browser was slow. What we really want is we want to make the browser fast. And for that, we have GWT mock utilities. They allow us to kind of mock up some of the browser functionalities. And that gives us mock views. Now let's look at presenter, what that actually looks like, because you want source code to understand how it works. So this is the presenter. We are now creating the presenter. And this presenter is called Phone Editor. The very first thing the presenter does is declare an interface. And this is the interface of the view will implement. And so let me just go back here. You see this piece of UI at the bottom where we have a label. We have home, mobile, and work. That's the label. Then we have a text field, which has the phone number. And then we have a cancel button and a save button. So there's 4 pieces. And what we're going to do here is define the methods for those 4 pieces. So here we have get save button. And we have get cancel button. Get number field, get label picker. So that's it. That's all we need for the interface. And notice that get save button does not return a button, but it has click handlers. And the reason is that has click handlers is really, really simple. It just has the click method. Maybe a couple other silly things. The button class has lots and lots of functionality. And we don't want to test all that. We don't want to rely on all that. We just want has click handlers. The number field, that's a text field. That's a very complicated piece of view inside the browser. All we care about is that it has a value, and that value can be a string. That's it. So that's all that we require. So we've defined the view. Now let's bind the display. That means tie the display and the presenter together. And this is very simple, straightforward, boring code. We say display.getSaveButton, add click handler. And we're going to give it a new click handler, and then on click, we call doSave. So when the user clicks the save button, we call doSave. The same thing, when the user clicks the cancel button, we call doCancel. That's really easy. Now when the user, let's see, edit phone. So when you edit a phone number, what we want to, when you start editing a phone number, we need to copy the values. We need to copy the phone number and the label from the model into the view. So our application creates the UI. So there's an empty label and an empty text field, and we have to take the two values from the model and we have to kind of paste them in there. So that's what it says here. Display.getNumberField, set value, and then phone.getNumber. So very straightforward. The save method is very simple. It does the reverse. Instead of putting the values in, we're taking the values out. So we say model.setNumber, model.setLabel, and then we say display.getNumberField.getValue. So the nice thing is that this is all easy code. Anyone can write this. I just take these fields and I copy them there, and when I save, I take these fields and I put them back there. And a part of the saving, I also have to send it to the server, of course, so I'm going to do that now. We have our nice helper classes. So it's real simple. Service.execute, and I create a new action. The action is update phone. I send that to the server. I have my helper object, updated phone, and when the update happens, I close the user interface. They're called teardown. That's it, just wire pieces together. So one other trick we want to do is dependency injection. It sometimes sounds like a really big word and you think, oh, we have to use these complex tools, but really it's just a pattern. You can do dependency injection by hand, downloading no tools. You just write it. And the pattern is very simple. You have no global variables. There's no special object in your application that you access that has all the capabilities on it. So there's no singleton or static that you say get global editor and get global this. Dependencies are instead pushed in, they're injected, preferably via constructor. And it's not hard to do manually, it's just boilerplate code. You have to type a lot of code. But I think we kind of recommend that you use gin and juice. Use gin on the client side and juice on the server side. So some of you may have heard of juice for dependency injection in Java code. Gin does the same thing inside of Google Web Toolkit. So I'm going to show you this slide of how to do dependency injection by hand. So that's when you type the code. Now there's going to be a lot of code on this slide, and afterwards I'll show you the simple version with gin. But I want you to read the slide from the bottom up. So start at the bottom and then read upwards. So the very last line of the slide is what we want. We simply want to say contactviewer.go. That's the only thing we want to do. But in order to do that, we need a contact viewer. So we have to create one. So if you look in the three lines above it, you see that we create a new contact viewer. Contact viewer is new contact viewer, and then it has 4 parameters: contact widget, phone editor, RPC service, and event bus. So now we need 4 things. So look the 4 lines above that, and you see that we create those 4 things. And we keep creating things until we have created everything that we need, so that we can do the very last line of the slide. So that's dependency injection. You write the thing you want, and then above it you create what you need, and above that you create what you need to create that, and you keep going until you have nothing left to create, and then you're done. Now that looks good, but let's say we're looking at this code, and now we decide the phone editor needs a new voice service as another parameter to inject. Now usually when you have all your widgets tied together, way down here you need a new voice service, then you have to add it to a constructor here, and then maybe add it to a constructor here, and then a setter, and then a setter, and you have to pass this object down many levels, even though you don't need it here, here, and here, but to get it here, you have to pass it down. With dependency injection, it's much easier. You just add the extra parameter to the voice service, the bottom one, and then up above, you create a new instance of it. That's dependency injection. Where you need it, you inject it. Now, I'll show you the same code with gin. That's it. We create a gin factory, and then we call factory.createContactViewer.go. And that does the exact same thing as the previous slide, but it's a little bit easier, right? So now the payoff of decoupling. First, I'll show you some of the work that goes into it. So we have a presenter here, and what we're going to do is we want to test our presenter. I want to make sure it works. So we have to create some mocks. Mocks are kind of fake things. So we're first going to create a mock contact service. You know this service over here on the server? We don't want to use the real service when we're testing the presenter, because then we're testing the presenter and we're testing the service. What we want to do, if we test the presenter, we want everything else to be a mock and fake, very controlled, so that we're only testing the one thing that we're testing. So we have our complex application, and we pop one thing out, the presenter, and we put it in the test bed, and now we test it. So this is the fake service. And all it does is it remembers the last action and the last callback. So you see the execute method just takes the 2 parameters and copies them into 2 variables. That's it. This is it. This is the mock. We're going to do something similar with the mock click event. Or the mock click event is just an empty class. Let's see, mock has click handlers. This is a fake class. Oh, sorry. Just get back to the slide here. Okay, so all we do is we take the last handler that was passed in, and we save it in a variable called last click handler. And that's it. The fire event is empty because we don't actually need to do anything. This is just a testing class. So this is some of the work that we do up front. We want to test the presenter, but first we need to create a mock service, a mock click handler, a mock this, a mock that. But those mocks we will reuse every time. That's just one-time work. So this slide here, it's one-time work. Now a mock has value. Again, some silly one-time work that we have to do. We want to save the last value that's put in. So the set value method just says last value equals value, and we'll just reuse this as well. We need a mock phone editor. Mock phone editor display, and this is where we set it up. We say the save button. Let's create a fake save button. The cancel button, let's create a fake or a mock cancel button. Label picker, create a fake label picker. Number field, fake number field. And notice that on these last two, even though one's a label and one's a text field, we use the same mock has value class because that's all we care about, that there's a string value. What does the get cancel button method do? It returns the fake cancel button. The get save button returns the fake save button, and so on. So very boring code, and this is what we want. Because if the code is boring, then it's easy to write, and it's easy to make it correct. And we're only doing the mocks once. So we want to do them once, and then forget about them, and use them over and over again. So now, finally, we get to do the test. We've written all these mocks. We want to test our presenter. So we want to test the save button. Will my presenter work when I push the save button? Will it do what I expect? So we need a service. So let's get a fake service. We need a display. Let's get a fake display, a mock display. We need a contact detail ID, just one to test with. Now we set up before and after values. When you do a test, you want to say, this is the data I have before. This is the data that it should look like afterwards. And then I do my test, I push the save button, and then I compare the output with the after values. And if the two match, my test is success. If the two are different, my test fails. So the before value is a home phone number, 123-456-7890. Then the after values, I'll make a copy of the before, and what I want is actually now a work number, and then 098765, etc. So that's before and the after that I want. Now we're going to run it. So we instantiate the editor. We call edit phone. That means start editing. And then on the view, the mock view, we set the value. We change it. So it was home. We change it to work. We take the number field, which was 1234, and we change it to 098. And then on the save button, we send a mock click event. So we tell the presenter, someone clicked, here's the event. And then we verify what happened. So we look at the last action, and we assert that it is exactly the way we expect. We check the phone number, the actual phone number, and we compare them. Assert equals the expected value and the actual value. Assert equals expected value and actual value. If these are correct, that means the presenter correctly copied the numbers from the view into the model. That's great. So that's the payoff, that's the win right there. You can write this test, and you're only testing the presenter. Everything else is a mock, everything else is fake. So if your view is broken, your server is broken, maybe you have a bug here and a bug here, but if I'm only testing here, I can find this bug. If I test both places, maybe the bug compensates each other and I don't see it, because this bug masks that bug. The third theme was striving to achieve statelessness. This is more general advice, but it talks about kind of your server architecture and the fact that you want disposable things. You don't want objects in different states that are brittle, that can break easily. Just like the model objects that we had. Don't have a single model object that you change and then have to roll back in very special conditions. You create one, and you create a copy. And when this one's the new one, you send it around. And if you want to throw this one away, you just throw it away. Disposable clients is really talking about allowing the user to hit F5 to refresh their page. Maybe their browser crashes and they go back in. Maybe they bookmark your page. Maybe they open up customer number 123, and they hit bookmark, or they copy and paste the link and send it to another user. You want that to work. Now I've talked about this, disposable model objects. That's when you, instead of having one contact, you allow multiple copies and you send them around. Now kind of the final piece is the history support. And here's a way of doing that. You remember this slide where we had the event bus and we pulled everything apart? And what we do is we just add another place service to the event bus, which keeps track of where the state of the application is. So maybe I push a button that says, go to contact details screen. That goes on the bus, and the bus tells the place service that needs to update, and the place service can fix up the page and move the pieces around. So let me go over the things I had in the beginning. If you remembered nothing else, get browser history right and do it very early. Use an event bus to avoid spaghetti. Pull all that data apart. Use dependency injection and ModelViewPresenter for the win, for success. And always think about these themes. Everything is asynchronous. Just to embrace it. Always decouple. Always things that are tied together, try to pull them apart. And strive to achieve statelessness. Here I have a link of the main GWT site where you can find documentation. The overview documentation I think is in Russian, or can find it in Russian at least. And there also the community, download the source code. Also, for those of you thinking about using GWT or already using it, I really recommend that you use the Google plugin for Eclipse. Download Eclipse if you don't have it. Hopefully you're already using it. And download the plugin. It will make development with GWT much easier. It has lots of tools and capabilities, and we're constantly updating it. So that's it. Thank you very much. So since this is the last session, I'm sure we have time for some questions if you like. And I'm sure we have people here that can translate, so if you want to ask a question in Russian, we can get someone to translate for us.
Would you recommend some best practices when we want to build project with Maven, a GWT project with Maven? Could you provide some information about it?
So best practices for GWT with Maven. So there is some community support for Maven. The GWT project itself really doesn't do anything with Maven. And this is one of the nice things of GWT being open source, that the community can create other third-party libraries. They can do projects with other build tools. So I guess my recommendation would be make sure you're in touch with that part of the GWT community, because I think they've done a pretty good job of making sure that the jar files from the GWT open source site get moved into the Maven repository fairly quickly, and that builds work well. Yeah.
I have a question. Why do we need a fake service before calling the real one once we're decoupling?
So why do you need a fake service instead of the real one?
Yeah.
So I have all my client code. I have my model, my view, my presenter, and all my UI widgets. I have my entire site. And I've written everything, or it's all code that I maintain or someone else maintains. And then on the server, there's a bunch of code too. And there could be a bug anywhere. There could be lots of bugs. And as a developer, if I test the whole thing and I hit the save button and something goes wrong, I don't know where to look. I have to look everywhere. If I make everything a fake, the service is a fake, the view is a fake, everything is a fake, and it works, then I know all the mocks are good, my tests are good, and I make one change, and I only test the presenter, and the presenter is the only thing that's different from last time, and it stops working, then I know the presenter's broken. If I test presenter and the real service and my test breaks, I only know that the problem is here or here. Now I have to look 2 places. So if you mock everything out, except for one thing that you're testing, then hopefully you know exactly where the problem is. And then if you combine that with continuous integration, you have a server running that every time you make a commit, it runs all your tests. And when you commit something that breaks, it will tell you.
Sorry, I actually was asking fake service when you were talking about decoupling with event bus. So it's like you make a change, you call the fake service, which updated the local cache. And only after that it calls the real
oh,
service.
that fake service.
Yeah.
I'm sorry. Yeah, so why do you... in the fake service, we call the real service. So this is the wrapper that deals with caching and special abilities early in the talk. So what you want to do is make sure that the client code doesn't know what service it calls. I could write my code so that when I hit save, I call the real service directly, or I could put a fake service in place, which is a wrapper. And so the fake service has to also call the real service, so I actually update the server. I guess maybe your question is, there's a different way of doing this. You could call the fake service. The fake service calls the event bus, puts it on the event bus, and then the event bus could call the real service. Is that what you mean? Yeah. Okay. So that works too, and that's kind of like what we call an optimistic UI. So when the user hits save to make a change, in that case, you update the UI and you tell the user, yes, it worked. But there's still this event on the event bus. And maybe a few milliseconds later, the event has to travel to the server. And maybe the server says, you're not allowed to do that. Or someone else made a change. Then the result comes back. And then you have to tell the user, the thing that we just showed you, that you updated, actually didn't happen. That can be a really good design because the user gets very quick feedback. So Google Wave is an example where you can type and edit a wave, and when the client loses connectivity with the server, you can still keep going for a little bit. But then it starts to warn you and say, ooh, be careful, we're not saving real time anymore. Answer your question? Okay. Next microphone. We're calling time. All right, thank you. I'll be in office hour section, so the GTUG lounge if you have any more questions. Thanks.